PPS-CF. And its biggest advantage is not this metallic sound, but its chemical and temperature resistance, which I couldn't even measure with my equipment. Welcome back to my tech farm. Qidi PPS-CF filament or polyphenylene sulfide reinforced with carbon fibers. And the price of this spool is 130 euros for me, and this is only 750 grams spool. And I bought it myself because Qidi at that time didn't promote filaments, only printers, and I bought it from Patent Donations. But today I even have the budget from the polymaker who became a channel sponsor to buy any filament I want to test. Few specifications from the website. Heat resistance up to 264 degrees Celsius. This means my temperature tests don't have too much sense because I can go up maybe to 230 degrees Celsius, but we will see how hard this is at that temperature. Excellent flame and chemical resistance and great mechanical properties. Ultra low water absorption. And few limitations. It cannot be used with a 0.2 mm nozzle, requires a very resistant nozzle, and high printing temperatures. And what is very typical for this filament is that metallic sound. So I print some bell or maybe some other parts to see how it sounds. Now let's see some print settings, and we have different informations on the box and on the website. Here you can see them side by side, but info from the website: the print temperature between 310 and 350 degrees Celsius, bed temperature 100 degrees Celsius, and the speed up to 100 millimeters per second. And they recommend some drying if necessary between 100 and 140 degrees Celsius between 8 to 12 hours. It's time for unboxing. Same information on the sticker like on the box. Usually they have resealable bags, but I'm not sure about this one. Maybe on this side, but look how small is it. There is a desiccant, and again same print informations on the spool too. End of the filament is glued. Let's see how brittle is it. Oh, very brittle. Let's measure it. I made this tool, you can download it from printables. With this we can measure the brittleness of the filament and we can compare it with other materials. Because of this curve, it has some start bending of 28 degrees. And now let's measure when it will break. I think it was 70, but I will analyze the footage. So very brittle filament, it may break inside those Teflon tubes in some printers. I had a lot of problems with K2 Max with this. Oops. I dried the filament few hours on 70 degrees Celsius. Filament is loaded and the printing will be on texture PR sheet with some glue on it. Settings in the slicer and profile for this material already exists, only I changed the temperature from 320 to 340 degrees Celsius. I tried to use my experience with the previous PPS material I tested on this channel. 6 will be the maximal flow rate, and the part cooling I reduced the default settings from 30 to 20%. And I'm uploading this file over the network, and I can start the printing. Start of the printing is nice, and this view to the nozzle always impressed me on the Qidi Plus 4. It's printing those last few vertically printed test objects, and except the telephone foot, this printing looks really nice. Those layer lights are quite hidden. The bed cooled down, and even through the door I can feel some unpleasant smell. And it's removable, but definitely I need some flexing to remove other objects too. And the printing is really nice this time. There is no elephant foot. I raised the Z offset by 0.05 mm. The question is, should I save it or it will affect my PLA settings, but on this printer I want to print only these high temperature filaments anyway. This is a replacement part for my wife's hairdryer. It fell down and this plastic part broke. This element here is just to support the upper part, so it is printed with the bridging. The start is very important, a lot of small circles. I don't know about you, but for me this looks beautiful. I hope dimensions will be correct. It's finished. Beautiful surface. This is the hair dryer, and theoretically this should withstand quite big temperatures. Let's see the dimensional accuracy. Perfect. And this will be so-called diffuser, I think. These are holes for M3 bolts, and of course it's not for me. Before I finish this, I want to check one more thing, because I know many of you will be concerned about those carbon fibers, which I think they are melted into plastic, but this is still a hair dryer, and that blows the air, and I don't want anybody to inhalate those fibers. So I will blow to this white paper towel, and if I will find even one fiber on it, then I'm reprinting this from different material. Okay, it's still wet. Let's check it under the microscope. Actually, I find something, but I'm not really sure. This bigger one is probably not fiber, because here you can see the filament, so it is too big. But there are those smaller black spots, and since I'm not 100% sure, just in case I reprinted this from the flame retardant polycarbonate. I still think that PPS may be better because of the higher temperature resistance, but in this case I feel more comfortable if you don't have those fibers, but there are many other applications where we can use this material. I'm checking the shrinking, and actually there is no shrinking. I'm measuring above the elephant foot. It's even bigger a little bit, and this is a sign that I could dry it a little bit more, but it will be tested as it is. The reason for this are those micro water drops in the nozzle that will boil and push out a little bit more material. This is a good method to check if your filament is wet, but unfortunately only after the printing. That's why manufacturers should place this kind of filaments on temperature resistant spools. Carbon spools are okay, but the question is only the glue which is used here, and this information should be provided on the sticker too. Last time the PPS material I compared to polyfilamide PPA, but I think its closer competitor should be PET-CF. Tensile test with horizontally printed objects. As you can see, it is stronger than PET-CF, and only some PPA materials are stronger than this value. Layer adhesion with vertically printed objects. With so weak layer adhesion, I don't want to continue this testing. What? Okay, let's give it a try. New print settings: 65 chamber temperature, 370 nozzle temperature, and 0 part cooling. I will have 4 test objects for the better statistics and more layer printing time. I maximized the temperature on the nozzle and inside the chamber, and I completely disabled the part cooling, and looks like it will be finished correctly. I was afraid that I should add some object next to it for the layer to have more time to cool down, but yes, at this moment it's completely finished. Well, actually I'm surprised. They still look quite good, only from inside that one edge is a little bit more rounded than it should be. This is my rating for the layer adhesion with these test objects, and we can see that this is weak. What do you think? What will be the new break load with these improved settings? This also means that PPS layer adhesion is very sensitive to settings, even more compared to the ABS. Definitely should pay attention to this. Even PET-CF has great layer adhesion, but let's concentrate on these two materials. This is what we will get with the default settings. Well, actually even less, because a reminder, I raised the temperatures from 320 to 340 degrees, because this is the default settings for this material in a slicer. And if we change the settings from this to this, look at this huge difference in the layer adhesion. And now I have a question for my Patreon supporters: which number to add into that summary table, because I don't want to add this number. If somebody will search for this material, he will just skip it because this is very weak. If you agree, I will add the average between these two numbers, which is 44.6, and I will add the comment note so more information is in the video. Is this okay? Shear test, and first with vertically printed test object. And it's affected with that weaker layer adhesion. And now horizontally printed, and I'm expecting higher loads, that's why I changed the scale here. PET-CF is stronger in both cases, but this value for the vertical object can be improved if we use those optimal settings for the better layer adhesion I explained earlier. The twist test with horizontally and vertically printed test objects with the same dimensions. This is horizontally printed. 1.5. Vertically printed, 1.5. I think both test objects are affected with this weaker layer adhesion. This one printed vertically directly, and this one printed horizontally. Can you see that gap? Weaker layer adhesion sometimes results also weaker wall adhesion too. In both cases, PPS-CF is affected with that weaker layer adhesion, but I'm not reprinting these test objects, they go to the table as they are now. 3-point bedding test. Distance between supports is 50 mm, and these loads will be placed one by one, and I measure the deformation after 130 and 60 seconds. Having only one object in this test may be boring, but pay attention to that additional deformation during this 1 minute. Now the load is 5 kilograms, and not even the load of 10 kilograms will make additional deformation during this 1 minute. This load was nothing for this PPS-CF. Both materials are very rigid, little bit less deformation with the PPS filament, but what is very impressive, absolutely no additional deformation during this 1 minute, not even under 10 kilograms. Impact test with this half kilogram hammer, and sometimes weaker layer adhesion will result better impact resistance. Let's see it. Zero position. It's not completely broken, which is not too often the case with these carbon fiber reinforced materials, but let's analyze the footage. These are the edge positions of the hammer, and from difference in height I can calculate the breaking energy. It is noticeably tougher compared to the PPS-CF. The creep tests the deformation under constant load, and I have several tests in the progress, this time all black filaments, PPS-CF, PHT-CF, graphene reinforced PLA, and graphene reinforced PETG. The load is 1.25 kilograms. Interesting, surprisingly small star deformation on these two. 12.46. They will be measured every day, but in the video let's jump in the time. This is day 5, time for the last measuring. Wow, almost no additional deformation on this PPS-CF. And just an interesting information, it had a bigger initial deformation than this PHT-CF, but absolutely no creeping, and here now the deformation is bigger than the PPS-CF. Both materials are good against the creeping, but this PPS-CF, not only that it has small deformation compared to the PET-CF, but look at these changes. This is just an inaccuracy in the measuring, but basically no any kind of creeping during these 5 days. Temperature test in the oven, and probably I will reach the maximal temperature of my equipment and there will be no deformation, but let's give it a try. I jumped in the time and this is end of that testing. And I stopped the experiment on 230 degrees Celsius. And I checked the hardness of this test object, it is completely okay. Probably we can even operate on this temperature. And summary of our results on one place. And before I add this one line to the summary table for my Patreon supporters, I'm asking them which value should I add into the layer adhesion. This is very important property and I'm not sure should I add the lowest value or the average of 2. I will wait 1 day before I upload that summary table. About that layer adhesion test, not too scientific approach because I changed too many things, but I was just curious what is the maximum what I can expect from this material. And with polymaker PPS-CF, actually I checked there the layer adhesion function of temperatures, and there those 340 degrees Celsius was the sweet spot where I can notice some significant increasing in the layer adhesion. And after this it is not worth to go too much higher. It looks like in this case that temperature is a little bit higher, because I don't think that reducing the part cooling from 20 to 0% is so significant, or the chamber temperature from 50 to 65. Probably it has some effect, but very minimal. And soon I will test Bamboo Lab PPS-CF and ask me to test it on H2D. And also YX Polymer will send me their PPS without carbon fibers, and I'm very curious what can we expect from the raw material compared to the carbon fiber version. I hope you will follow me to that video too. Huge thanks to all my Patreon supporters, because as you can see, without you I couldn't make this kind of videos. I earn only approximately $10 per video, and now together with the Polymaker basically I can buy any filament I want to test. Thank you for watching this video and happy printing!